Alright, so this is where we left off in the last half of the video. We had this expression. What a long expression. You gotta wonder, is math really my subject when you get to this point? But I'm going to hold your hand and I'm going to help you out and I'm going to help you solve this step at a time. One step at a time. So what do? I'm going to expand this negative a half to everything. So we have the negative of cosine of 2x minus 1 e to the x over 2. And then negative half plus. Now remember, this 2 goes to this guy. And it also goes to here. But don't forget, we have this lone 2 still here. That's a constant multiple, which means it's 2 times negative 2. Which means it's negative 4. So 2 sine 2x. That's just something to keep in mind, because this negative halves to everything. This 2 is only to this part of the integral. So negative a half times 2 sine 2x e to the x. So that's just minus sine of 2x e to the x. Negative a half times negative 4 e to the integral e to the cos, whatever, doesn't matter. So negative a half times negative 4, well that's just plus 2 times the integral of e to the x cosine of 2x dx. You think, man, we're running around in circles. We're getting an integral, that's fine. We're getting a partial integral, that's fine, because that's what integration by parts is, right? We've integrated something, that's an integration, we got an answer. But we still don't know what to do with this guy. Actually, there is something you can do, because remember I was saying that if you know how to integrate e to the x sine x or e to the x cosine x, you would know what to do next. And I'll show you exactly what to do, in case you don't know. Remember, the integral that we are trying to solve at the end of the day is this. And that's equal to all of this. It's equal to all of this. Which means that we can algebraically manipulate this as if it was like any other algebraic expression. Which means I'm going to subtract 2 of this integral from both sides of the equation. I'm going to write dot 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 because I can't be bothered rewriting it. So it's the integral of e to the x sine squared of x dx minus 2 times the integral of e to the x cosine of 2x dx is equal to dot 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 because I can't be bothered writing it. And you think, dude, this is insane, man. What do I do now? And I'll tell you what we do, man. Recall the word trigonometric identity. Now we know that cosine of 2x is obviously going to be the one. Well, it's not obvious, but that's the one we have to manipulate. And we know that this is either equal to cosine squared x minus sine squared x. It's equal to 2 cosine squared x minus 1. It's equal to 1 minus 2 sine squared x. Which one do we choose? It's the last one, and I'll show you why. Because what will happen is if we make cosine of 2x equal to this, that's fine. We'll get a e to the x sine squared x term, which means that we can sort of equate it to this integral, but then we'll have to solve the integral of e to the x cosine squared x, and we pretty much have to do everything that we did in part 1 again. But then we'll run back to this problem again, and we'll, more than likely, I haven't actually done it, but that's probably what will happen. So this is the likely candidate what we have to choose. So let's rewrite it. So now it's the integral of e to the x sine squared of x dx is equal to minus 2 times the integral of e to the x. Instead of cosine of 2x, it's now 1 minus 2 sine squared x dx. Alright, cool. That's all fine and dandy. So now it's the integral of e to the x sine squared x dx. Let's expand it out. So now this is minus 2 times the integral of e to the x, because e to the x times 1 dx, and then minus 2 times minus 2, so it's plus 4. Integral of e to the x sine squared of x dx is equal to dot dot dot. Now what do you know? We have 4 of this integral and we have 1 of that integral there. So we can add them together. They're like terms. How cool is that, man? So now I can rewrite this as 5 times the integral of e to the x sine squared of x dx minus, sorry, that's a terrible minus sign, but what's the integral of e to the x? So that's e to the x, right? So it's minus 2 e to the x is equal to dot dot dot. Now I don't need to write dot 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 anymore because I am going to actually start playing around with that side of the equation. So now, this is 5 times the integral of e to the x sine squared x dx is equal to, I'm going to add 2 e to the x both sides, but don't forget that we had this term here. So I'm going to rewrite that. So that's the negative of cosine 2x minus 1 e to the x over 2. But recall, I had negative sine 2x e to the x. Well, I'm going to backtrack a little, and I'm going to multiply top and bottom by 2. Just so I can have a lowest common denominator. So that's minus 2 sine of 2x e to the x over 2. And that's minus 2 e to the x plus c. Well, I won't write the plus c yet. So now this is 5 times the integral of e to the x sine squared x dx is equal to negative cosine of 2x minus 1 e to the x minus 2 sine of 2x e to the x. I'm going to make a lowest common denominator here as well. So multiply top and bottom by 2. So that's minus 4e to the x all over 2. Now the final step. We were so close to solving the equation. I now just need to divide both sides of the equation by 5. So now the integral of e to the x sine squared x dx is finally equal to negative cosine of 2x minus 1 e to the x minus 2 sine of 2x e to the x minus 4 e to the x all over 5 times 2 is 10 plus c. And that is the final answer for this problem. How ridiculous. So I could factor out e to the dx because it's common, and I could expand this e to the dx out because I'd have a minus 5 e to the dx, and then I could just factor out the e to the x and I could get this cool little expression. But I'm not going to do that because the video is already 7.5 minutes long, but that's how you solve the integral of e to the x sine squared x dx. So I'll just show you what I had in part 1. So I started from here, did a trigonometric identity, reduction formula, manipulated, did integration by parts twice. And then what I did is that I expanded the negative 1/2 term out. And then I only dealt with the left-hand side of the equation because I made the conclusion that the integral that I'm trying to solve anyway was e to the x sine squared x dx, and that's obviously going to be equal to what I'm trying to do here. So then I realized that I can algebraically manipulate this like any algebraic equation. And I subtracted this integral from both sides. And then what I did is, where am I up to? Oh yeah, here. I realized that the integral of e to the x cosine of 2x dx, well, I know that all the trigonometric identities for cosine of 2x, and I chose the one that I knew would give me 2 sine squared x. And the reason why I know that it was this identity is because I knew that it would eventually equate to having that same integral back, but having extras of it. So like x plus 4x, which is 5x. And that's the same thing I've got here. I had 1 times the integral of ex sine squared x dx plus 4 of them. And then what I did is I algebraically manipulated everything, and then I divided both sides of the equation by 5 and plus c, and I've got my final answer. And that is a really fun integral. In the next video, I'm going to try and solve e to the x cosine squared x. I don't know if it's possible. I'm going to have a try. Anyway, this is so cool. I don't know. Doesn't that just make you feel good knowing that, like, that's possible? And this is like, it looks so simple, but it's not. And doesn't it make you wonder how a problem like this can give you a problem like this? I don't know. Maybe I'm just weird. Anyway, I'll see you later.